Have you ever wondered where the power that drives your car or heats your home actually comes from? It's a question that has sparked curiosity and innovation for centuries. The quest for power, for energy, is an enigma that has led to the creation of marvels of engineering. From the roar of an internal combustion engine to the silent collection of sunlight, the methods of harnessing power are as diverse as they are fascinating. The answer lies in engines of various types, each with its unique method of power production. Engines, the heart of power production, come in all shapes and sizes. Let's dive into the world of power-producing engines and explore the unique properties of a few key types, namely internal combustion engines, steam engines, and engines driven by renewable energy sources. First up, we have the internal combustion engine, a marvel of modern engineering. These engines operate on the principle of igniting a fuel-air mixture within a confined space, creating a high-pressure gas that drives the pistons. They're known for their high power-to-weight ratio and efficiency, making them a popular choice for vehicles and portable machinery. However, they come with a hefty price tag in terms of environmental impact, contributing significantly to carbon emissions. Next, let's time travel a bit and look at steam engines, the workhorses of the Industrial Revolution. These engines work by heating water to produce steam, which then expands and drives a piston or turbine. Steam engines are robust and reliable, and they can run on a variety of fuels. However, their efficiency is lower than that of internal combustion engines, and they are bulkier, making them less suitable for mobile applications. Finally, let's venture into the realm of renewable energy sources. Here we find engines driven by solar and wind power, among others. These engines convert natural energy sources into mechanical or electrical power, often through a turbine mechanism. While they have lower power outputs and depend on weather conditions, they boast an unbeatable advantage: zero emissions. This makes them an increasingly popular choice for power generation in a world that's more conscious of its carbon footprint. So, as we can see, each engine type has its strengths and weaknesses, making them suited for different applications. As we continue on this journey, we'll delve deeper into each of these engines, exploring their intricacies and the cutting-edge technologies that drive them. Now let's delve deeper into one of the most common engine types, the internal combustion engine. These engines have been the driving force behind our vehicles for over a century, powering everything from cars to airplanes. They work on a principle known as the four-stroke cycle: intake, compression, combustion, and exhaust. In the intake stroke, the engine draws in a mixture of air and fuel. The compression stroke then compresses this mixture, making it highly explosive. The combustion stroke ignites the mixture, releasing energy that drives the piston down. Finally, the exhaust stroke expels the spent gases, making room for a new cycle to begin. But it's not all roses with internal combustion engines. They are notorious for their inefficiency, with only about a quarter of the energy from the fuel actually used to move the vehicle. Plus, they emit harmful greenhouse gases, contributing to global warming. Despite their widespread use, internal combustion engines are not without their drawbacks, particularly in terms of environmental impact. Moving on, let's explore the workings of another engine type, the steam engine. This ingenious invention operates on a simple principle: heat turns water into steam, and steam exerts pressure. This pressure is then used to move a piston, which in turn generates motion. Picture this. In a typical steam engine, water is heated in a boiler, creating steam. This steam is then directed into a cylinder, causing a piston to move back and forth. The piston is connected to a wheel, or a series of wheels, and as it moves, it turns the wheel, generating motion. But the power of steam engines extends beyond their mechanical operation. They were the driving force behind the Industrial Revolution, powering factories, locomotives, and ships. And while they may not be as common today, they still find use in applications like power generation and desalination plants. While not as prevalent today, steam engines played a crucial role in the Industrial Revolution and remain a fascinating area of study. Finally, we turn our attention to the future of power production: renewable energy. This isn't a passing trend, but rather a technological revolution, a shift in the way we generate and consume power. The engines of tomorrow aren't just about horsepower anymore. They're about harnessing the power of nature, using the sun's rays and the wind's gusts to fuel our world. Solar power works by converting sunlight into electricity with photovoltaic cells. These cells generate an electric current when struck by light, a phenomenon known as the photovoltaic effect. Imagine an engine where the fuel is light itself, a source that never runs out as long as the sun shines. Wind power, on the other hand, operates on a more mechanical principle. Wind turbines capture the kinetic energy of the wind and convert it into mechanical energy, which can then be transformed into electricity. It's like a windmill on steroids, an engine powered by the invisible force of moving air. These engines, powered by renewable sources, carry the potential to lessen our dependence on fossil fuels. They offer cleaner, more sustainable alternatives that can meet our power needs while also protecting our environment. They are the engines of the future, and they're already here, working quietly in the background, powering our world with the forces of nature. As we look to the future, renewable energy sources offer a promising path towards sustainable power production.